Peace be unto you and your family. 11th Standard Chemistry, Refresher Course Module, Unit number 16, Carbon and its compound we are going to discuss in this video. Dear students, after this video, you may know about explain the special features of carbon, know about the isomerism, compounds having same molecular formula but a different structural formula, and allotropic forms of carbon compound, classification of the organic compound and name them based on IUPAC rules, identify the functional group of organic compound, understand the difference between soaps and detergent. Come to the introduction part of this video. Carbon is one of the most important non-metallic elements. Antoine Lavoisier named carbon from the Latin word carbo, mean coal. Carbon, it is a main constituent of the solid fuel coal. Carbon is present in our muscles, bones, organs, blood and other compounds of living matter. The number of carbon compounds known at present is more than 5 million. Large number of things in our daily life are made up of carbon compounds. Carbon chemistry is also called as living chemistry. Organic chemistry, organic compound, living chemistry. Carbon compounds are classified into organic carbon compounds, carbon connected with other elements like hydrogen, oxygen, nitrogen, sulfur, etc. Example, methane, methyl alcohol, acetic acid. Inorganic carbon compounds containing organic compounds, inorganic carbon compounds are limited: oxide, carbide, sulfide, cyanide, carbonate and bicarbonates are major class under this. Carbon monoxide, carbon dioxide, calcium carbonate, sodium bicarbonate are example of inorganic carbon compound. Special features of carbon. Catenation. Catenation is binding of an element to itself or with the other elements through covalent bonds to form open chain, linear chain, closed chain compound, alicyclic. Carbon has greater tendency to form catenation. To form a catenation, some of the requirements are required. The valency of the element is equal to 2 or greater than 2, carbon valency is 4. The element has a tendency to form self bond with itself. Carbon forms self bond with itself. The carbon-carbon bond should be inert towards the chemical reaction. So, among carbon possess all these properties, therefore, the catenation properties of carbon is more than that of silicon, germanium, tin and lead. Tetravalency. The cell electronic configuration of carbon, atomic number 6, outermost elements of carbon is 4. That means carbon atomic number 6, electronic configuration 1s2, 2s2, 2p2. Valency cell containing 4 electrons. In the valency cell, we know 2s orbital has only one orientation, p orbital has 3 orientation. They are 2px, 2py, 2pz, s orbital containing 2 electrons and p orbital according to Hund's rule containing 2 unpaired electrons. During the formation of compound, one electron is promoted to 2pz orbital and the valency cell electronic configuration of carbon is 2s orbital containing 1 electron, 2px, 2py, 2pz orbital containing 1 electron. So, there are 4 unpaired electrons in carbon atom, therefore, carbon valency is 4. Carbon has the tendency to share its 4 electrons with the other atoms to complete its octet. This is called its tetravalency. carbon can form 4 covalent bond with the other element. Carbon 4 valence electron. We know hydrogen atomic number 1. Therefore, each hydrogen share its electron with the electrons of carbon. So, there are 4 bonds are formed between carbon and hydrogen. Carbon valence is 4. Multiple bond. Carbon is able to combine with other elements or with itself through single bond, double bond and triple bond due to tetravalency. In methane, the bond between all carbon hydrogens are single bond. In ethene, carbon-carbon bond is a double bond CH2, double bond CH2, and in acetylene, ethane, the carbon-carbon bond is a triple bond. Isomerism. What is meant by isomerism? The phenomenon in which the same molecular formula may exhibit different structural arrangement is called isomerism. Compounds having same molecular formula but a different structural formula are called isomers, and the phenomenon is called isomerism. Compounds have same molecular formula but a different structural formula are called isomers. Molecular formula C2H6O. We can write one alcohol isomerism and one ether isomerism. CH3, CH2OH, ethyl alcohol, ethanol. With the same molecular formula, ether isomerism, ether functional group O. When you divide the 2 carbon atom into 2, 1 carbon means methyl, another carbon methyl. Both these compounds having same molecular formula but a different structural formula are called isomers, and the phenomenon is called isomerism. Allotropy. Allotropy is a property by which an element can exist in more than one form that are physically different and chemically similar. The different forms of that element are called allotropes. Different allotropic form of carbon are diamond, graphite, fullerene, carbon nanotubes and graphene are all allotropic of carbon. Come to the general characteristics of organic compound. Organic compounds have high molecular weight and a complex structure. Organic compounds are insoluble in inorganic solvent, polar solvent, water, but soluble in non-polar solvent, organic solvents such as ether, carbon tetrachloride, toluene, acetone, benzene. Have low melting point and boiling point and are less reactive. Highly inflammable, easily catches fire, and volatile, easily vaporizable in nature. Mostly they form covalent bonds in nature. Come to the classification of organic compounds. Organic compounds are classified based on the pattern of carbon chain and based on the kind of atoms present. Organic compounds are classified into acyclic or open chain compound, acyclic, acyclic or open chain compound, cyclic or closed chain compound. Saturated compounds containing carbon-carbon bonds, single bonds are saturated. And unsaturated compounds, compounds having double or triple bond, ethene, ethylene, ethylene, acetylene are example of unsaturated compound. Acyclic, open chain compound. Cyclic compounds are classified into carbocyclic, only carbon chain. And another one is heterocyclic. Along with the carbon, some other elements are also present in the ring structure, closed ring structure. This is pyridine. Some more example, heterocyclic compounds, some more example is, in the place of carbon, one carbon is replaced by one oxygen, heterocyclic atom. This is called furan. And one carbon atom is now replaced by sulfur. This is your thiophene. And one carbon atom is replaced by nitrogen, NH. This is called pyrrole. So these are heterocyclic closed chain compound. Now carbocyclic again classified into alicyclic. This is cyclopropane, CH2, CH2, CH2. Cyclobutane, CH2, 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 CH2. Cyclopentane and cyclohexane, alicyclic and aromatic, benzene compound, benzenide compound. Then second classification based on the kind of atom. Hydrocarbon composed of carbon and hydrogen only. Hydrogen, carbon, no other element present in hydrocarbon. They are classified into alkanes, alkenes, alkynes. Alkanes general molecular formula CnH2n plus 2. There is a carbon-carbon single bond. All the carbon atoms are linked through a single bond. They are also called saturated compound. In alkene, general molecular formula CnH2n. There is a double bond between two carbon atoms. One or more double bonds are present. They are called unsaturated compound. Alkyne, CnH2n minus 2. Carbon-carbon triple bond. They are called unsaturated compound. These two are unsaturated. Single bonded compound called saturated compound. Test to identify saturated and unsaturated. First one is, take the given sample solution in a test tube. Add a few drops of bromine water and observe the change in color. If the given compound is unsaturated, it will decolorize bromine water. Color of bromine water is yellow in color. That yellow color is decolorized by the unsaturated compound. Saturated compounds do not decolorize bromine water. D means removal of color. Functional group. A functional group is an atom or group of atoms in a molecule which gives its characteristic chemical properties. A series of compounds containing the same functional group is called a class of organic compound. Classification of organic compounds based on the functional group. Alcohol functional group OH, molecular formula, common formula R OH. Example, 2 carbon eth, carbon-carbon single bond ane, OH all, ethanol. Aldehyde functional group CHO, common formula R CHO. Example, acetaldehyde, second member of aldehyde. CH3 CHO, 2 carbon eth, carbon-carbon single bond ane, aldehyde ale, ethanal or ethanol. Ketone functional group C double bond O, common formula RCOR. Acetone, when two alkyl group attached to CO, it is called ketone. Acetone, 3 carbon root word prop, carbon-carbon single bond ane, ketone, name end with one, propanone. Carboxylic acid functional group COOH, common formula RCOOH. Second member of carboxylic acid, acetic acid. 2 carbon eth, carbon-carbon single bond ane, COOH, oic acid, ethanoic acid. Ester, COO is a functional group. Like ketone, if you add 2 alkyl group, you will get ester. Methyl is attached to COO. This is your methyl, CH3 methyl. Here you have 2 carbon atom, eth, carbon-carbon single bond ane. Ester name end with O8, methyl ethanoate. And ether function group O. Like ketone and ester, when 2 alkyl group attached to O, it is called ether. Dimethyl ether. 1 carbon methane, carbon-carbon single bond ane, methane. Here you have 1 carbon methane, oxygen, methoxymethane, IUPAC name. What is made by homologous series? A homologous series is a group or class of organic compounds having the same general formula and similar chemical properties in which the successive members differ by CH2 group. Alcohol, aldehyde, ether, aldehyde, ketone, alkane, alkene, alkyne are example of homologous series. What are the characteristics of homologous series? Each member of the series differs from successive members by CH2 group. All the members containing the same element and functional group. They are represented by the general molecular formula CnH2n plus 2. And the members in each homologous series have same chemical properties but gradual variation in the physical properties. That means molecular weight increases, boiling point, melting point increases, gradual variation. All the members can be prepared by a common method. Nomenclature of organic compound. A set of rules were formulated by International Union of Pure and Applied Chemistry for the nomenclature of chemical compounds. IUPAC name. First prefix, then second point root word, primary suffix and secondary suffix. First come to the root word. Root word is given according to the number of carbon atom. 1 meth, 2 eth, 3 prop, 4 but, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, 10 tech. Prefix before comes. What are the functional group? Should be written before the root word. Fluoro, chloro, bromo, iodo, amino, methyl, ethyl. Now in the new nomenclature system, this amino comes as suffix, not as prefix. Primary suffix, nature of the bond, carbon-carbon single bond, name end with ane, double bond in, triple bond ine. Secondary suffix. The functional group, alcohol, aldehyde, ketone, carboxylic acid, acid amide, acid chloride, comes under secondary suffix. Alcohol functional group OH means the name end with all, aldehyde name end with ale, ketone name end with one, carboxylic acid name end with oic acid. Come to some IUPAC rules for naming organic compound. Identify the longest chain of the compound. Number of carbon atom of the parent chain, both functional group and substituent are present. Periodicity will be given to the functional group. Carbon chain is numbered in such a way that multiple bonds have the lowest possible locant number. In the case of alkene, alkyne, use the primary suffix, or in the case of functional group, use secondary suffix. Primary and secondary suffixes are joined. The terminal e of the primary suffix, ane, ene, ine, the last e is removed and replaced by all, ale, one, oic acid. Identify the substituent and use a number followed by a dash, hyphen, and a prefix to specify its location, 2-methyl, 2-methyl, and identity. Now, IUPAC name of various class of compounds. First, alcohol, 1 carbon meth, meth always comes with ane, methane, OH end with all. Aldehyde, 1 carbon meth, ane, aldehyde name end with ale, methanol or methanol. Then HCOOH, 1 carbon meth, ane, acid name end with oic acid, methanoic acid. 2 carbon alcohol, 2 carbon eth, carbon-carbon single bond ane, OH all, ethanol. 2 carbon eth, carbon-carbon single bond ane, aldehyde name end with ale, ethanol. 2 carbon eth, carbon-carbon single bond ane, carboxylic acid name end with oic acid, ethanoic acid. 3 carbon prop, carbon-carbon single bond ane, OH all, propanol. 3 carbon prop, carbon-carbon single bond ane, aldehyde ale, propanol. 3 carbon prop, carbon-carbon single bond ane, ketone name end with one, propanone. 3 carbon prop, carbon-carbon single bond ane, carboxylic acid name end with oic acid, propanoic acid. 4 carbon but, carbon-carbon single bond ane, OH name end with all, butanol. 4 carbon atom but, carbon-carbon single bond ane, aldehyde ale, butanol or butanol. 4 carbon but, carbon-carbon single bond ane, ketone name end with one, butanone. 4 carbon but, carbon-carbon single bond ane, carboxylic acid name end with oic acid, butanoic acid. 5 carbon pent, carbon-carbon single bond ane, pentane, OH name end with all, the position of OH is 1, therefore 1 pentanol. Then 4 carbon pent, carbon-carbon single bond ane, aldehyde name end with ale. There is no need to indicate the position of aldehyde and oic acid because they are always present in as the first carbon atom. 5 carbon pende, carbon single bond n, ketone name end with 1, position of ketone is 2. Therefore, pende n 2 one. 5 carbon atom pende, carbon single bond n, carboxylic acid name end with oic acid, pentanoic acid. Come to the next heading, soaps and detergent. Soaps are two types, one is hard soap, another one is soft soap. Hard soap is prepared by saponification of oils or fats with caustic soda. This reaction is used in the manufacture of glycerol. In this saponification reaction, soap is the main product, glycerol is the byproduct. Soft soap is prepared by saponification of oil or fats with potassium salt. Potassium hydroxide, here sodium hydroxide. Hard soap used for washing purposes and soft soap used for cleansing the body, bathing soap. Soap and detergent. Soap is a sodium salt of long chain fatty acid. Detergent, it is a sodium salt of sulfonic acid. Soap prepared from animal fats or vegetable oil. Detergent prepared from hydrocarbons obtained from crude oil. Soap its effectiveness is reduced when used in hard water. Precipitate is formed. It is effective even in hard water. Detergent. Soap, it forms a scum in hard water due to the presence of calcium 2 plus and magnesium 2 plus ion. Does not form a scum in hard water. It has poor foaming capacity. It has rich foaming capacity. Soaps are biodegradable. Most of the detergent are non-biodegradable. What is meant by total fatty matter, TFM? TFM is one of the important factors to be considered to assess the quality of soap. Higher TFM, a good bathing soap. So dear students, in this video we discussed about carbon and its compound. Classification and naming of organic compound, soap and detergent we discussed. Thank you for watching. If you like, please subscribe. Thank you very much.